Nowadays, nanotechnology is part of our daily lives. Continually improved with growing power and efficiency, this technology of the future is now able to accurately master the light of our computer screens and cell phones.
This is one of the applications we're developing here for small mobile units. This screen is covered with a very thin plastic surface, which has a highly complex structure. The white light enters here. As you can see, it's a very powerful and homogeneous source of light if you compare it to the normal screen you find on the market. Between the two screens, the difference is obvious.
This technology developed by the European project Napanil makes the luminosity of screens more efficient and less costly in terms of energy. In order to further develop this process, researchers had to invent a silicon stamp modelled on a micro and nanometric scale, able to modify the optical properties of transparent surfaces. Before it can be used, this miniature stamp must be reproduced on a larger surface. This is called nano imprinting.
Nano imprinting is a very important phase, where a small master stamp is imprinted and replicated several times. The surface with all the numerous replications of this figure will be used in the final imprinting process.
Duplicated on a large scale, the structures issued from nano imprinting are replicated on surfaces such as plastic, which will later be used for the screens of our cell phones. Once treated, this plastic will hold amazing optical properties.
The dimensions of these structures are less than 1 micrometer. The reason they are interesting is because they allow us to manipulate light and reflect it in different ways. We see it because the imprinted surface produces different colors.
Each color corresponds to an angle at which light crosses the imprinted surface. These nano surfaces capable of controlling the flow of light have already found other applications besides our cell phone screens.
Another application is the design of a light fragmentation element that can be integrated into windows to control the natural light, sunlight. That in turn translates into energy savings.
Thanks to Napanil, large area optical light deviation elements on glass can be integrated into windows, homogeneously redirecting natural light, allowing better lighting in buildings. Another field of application, the automotive industry. Nano imprinting will be used to produce high optical control surfaces to be integrated in transparent emissive displays. Unlike conventional HUDs, which project images, this layer will ensure brightness and contrast all day long.
Our goal is to create a windshield screen, an emissive head-up display, with such low production costs that manufacturers can integrate it into their mid-price range vehicles, thereby increasing driver safety on the road.